The fundamental theorem of algebra essentially states that any polynomial function of degree n, where n is greater than or equal to 1, has at least one zero. What that says is that if it's a polynomial, which means that all of the exponents are whole numbers, 0, 1, 2, 3, 4, 5, etc., that as long as it's at least linear or higher, there's going to be at least one, this should actually say complex, there's at least one complex number that will make the function equal 0. You know, any linear equation can be solved. A linear equation is going to be in the form ax plus b. All you've got is your x term and your constant. And if you set that equal to 0, you're always going to get an answer of x equals negative b over a. Would subtract b from both sides and divide by a. A quadratic, any quadratic equation where you've got ax squared plus bx plus c equals 0. If you take your quadratic and set it equal to 0, the zeros are the x values that make the y 0, and we know that that would be negative b plus or minus the square root of b squared minus 4ac all over 2a. Now this, the linear is always going to have, assuming that your coefficients are real numbers, or let me say rational numbers. If the coefficients are rational, if your coefficients are rational on this one, negative a over b would be a rational number over a rational number, which is a rational number. In the case of a quadratic, you could have two rational zeros. Now, a rational number is any fraction that can be written without using a radical. So you could have two rational zeros or two irrational zeros. Two rational zeros might be like 5 and negative 7. Two irrational zeros might be like 3 plus or minus the square root of 6. Or one rational zero, that would be in the case of having the radical can't just be a 0. So that would be if b squared minus 4ac is equal to 0. This would be b squared minus 4ac is greater than 0. Or you could have two complex zeros. If the thing in the radical, the b squared minus 4ac, is a negative. So as long as you say at least one complex zero, you're going to have here at least one rational zero, or two rational zeros, or two irrational zeros, or two complex zeros. So you could have a lot of different combinations with a quadratic, but you're going to have at least one answer when you set it equal to 0. At the very least, you're going to have negative b over 2a for your x value. What the fundamental theorem says is that if when you get up to cubes and x to the 4th, x to the 5th, et cetera, you will always have at least one 0.